Okay, so some of you are still having some difficulty with drawing resonance structures, and it'll be very important for you to make sure that you can do that, especially in terms of being able to draw the key resonance structure. So I'm going to just show you with some generic groups on an aromatic ring how you delocalize a plus and a minus charge. So we'll start with a minus charge. So remember, a minus charge is an extra pair of electrons. So the pair of electrons will form a new pi bond between the X and the carbon in the ring, and then the pi electrons will move to the carbon furthest away. So that creates my new pi bond, old pi bond, old pi bond, new lone pair on that carbon. Lone pair forms a new pi bond. Pi electrons form a new lone pair on the carbon furthest away. And Smithers is attacking me right now, so I'm a little bit distracted. So old pi bond, new pi bond, new minus charge. Lone pair of electrons forms a new pi bond. Pi electrons form a new minus charge. Minus charge, old pi bond, new pi bond. Lone pair of electrons forms a new pi bond. Pi electrons move back to the X group now, so that I have my minus charge back on the X. For a cation, what you're going to notice is that the resonance structures all look exactly the same as those for an anion, except I only move one arrow at a time. So pi electrons form a new pi bond. New pi bond, old pi bond, and now the plus charge is on the carbon that the pi electrons left from. Move the pi electrons, new pi bond, old pi bond, new plus charge. Pi electrons move, new pi bond, old pi bond, plus charge. Pi electrons move, new pi bond, old pi bond, plus charge. So when you have an aromatic ring with an atom bonded to it that has a charge, it doesn't matter what the group is that has the charge. I'll just use a minus as an example. I can only get the charge to these three carbons. The carbons next to the carbon that the group is on, or across from.